welcome Huang Hanmin, the Chair Professor of University of Science and Technology of China. His presentation is Palladium-catalyzed chemistry, a useful tool for a useful purpose. Distinguished guests, ladies and gentlemen, good afternoon. It is a great pleasure to tell you about palladium as the catalyst. So palladium played a very important role in the chemistry catalyst. Actually, in my title, I quoted a Chinese ancient poem, and this line is perfect to describe the role of palladium. It's a useful tool for a useful purpose, as it's said. I will approach this topic from the 4 parts. I'll talk about the important role of palladium in the chemical reaction and also the medicine development. We know that chemical industry is a key driver of global economy. And from this chart, you can see that globally, chemical sales is an important sector in many countries in the world. And in China is the top one in terms of chemical sales, far higher than the other countries. To achieve the fast development of chemical industries, a catalyst is an indispensable part. Catalyst has played a very important role in the progress of mankind. To some extent, a catalyst has supported the economic development of the world. Over 90% of the chemical products were done through a catalyst process. And every day, it needs 850,000 metric ton of catalyst. While palladium, as a very important metal catalyst, it participated in this reaction cycle. So going through the cycle, the useful chemical products can be produced, and the palladium reaction as a catalyst has covered many of the aspects in the chemical industries.
So this is the palladium. Why is palladium so active? Let's take a look at its chemical properties. It's only one without s electron. In other words, all the circuits are filled. And in terms of its chemical properties, it's soluble in aqua regia and hot sulfuric acid, as well as concentrated nitric acid. So we have different types of palladium, including elemental palladium, palladium chloride, palladium acetate, and the palladium carbon. In terms of the demand, global demand for palladium in 2022, about 85% of palladium is used in autocatalysts. Only 5.9% was taken up by the chemical industry. However, if you take a look at the patent related to palladium, every year more than 3,500 palladium-related reaction, catalytic reaction patents have been filed on that front, showing the important place that palladium has occupied in the chemical industry. Let's take a look at the history of palladium and palladium-based catalysis. In 1894, American scientist Phillips used palladium and actually used this synthetic solution, put the synthetic solution into palladium, and found that palladium chloride can react with ethylene. The Walker reaction wasn't discovered until 1959, when Haffer discovered the chemical, or identified or figured out the details of the chemical reaction. So these reactions like Hack reaction and Kumada coupling, Stilo coupling, and BH coupling, all these are some of the major milestones in the history and evolution of palladium used in various types of chemical reactions. As you can see, some of the commonly used palladium-based catalysts. Generally speaking, if you do organic synthesis in any organic synthesis lab, you will find all kinds of palladium-based catalysts, with some of the most commonly seen ligands used to stabilize the palladium and to bring out its potential so that it performs better. So you will when you do chemical reaction, there will be an active ingredient intermediate. When you find a effective active intermediate, there are chances that you identify a new type of reaction. So here I listed some of the very famous reactive intermediates, such as the ones used in BH coupling reaction as carbon insertion reaction and Catalani reaction in a cyclone format, as well as the palladium-catalyzed amine methylation, which is called Huang complex that we discovered ourselves. So next up, I'm going to spend a couple of minutes talking about how palladium catalysis is used in medical and pharmaceutical processes. As I mentioned, that palladium is very active in that it's the only element without an outer s electrons. As a result, it has a relatively high coordination activity with olefin. In other words, it's capable of activating olefin. In addition to that, it has moderate electronegativity. As a result, it can form rather stable bonds with carbon. In other words, it can catalyze some very good conversion reactions. In addition to that, palladium has varied valence from 0 to 1 to 3 to 4 valence. Such variety can contribute to chemical reaction and conversion. So this represents some of the reasons at the electrical level why palladium is so useful. Let's take a look at the Walker reaction, Walker oxidation reaction back in 1982. Such reaction turns things. Walker reaction is used in pharmaceuticals. They play a very important role. Walker reaction, a key here is that it's capable of synthesizing cochineal, and which is very interesting. Another reaction is TT reaction that was identified by a Japanese scientist back in 1965, and he published this reaction on a paper. You can see the conversion process here. Rx and NUH turn into R1 NU step by step, step by step. Let me give you an example. This is also used, the TT reaction is also used to synthesize natural products. For example, Pseudomonas and eucalyptol are synthesized with this reaction. Another reaction is a Heck coupling reaction that won the inventor a Nobel Prize. It's capable of coupling, as you can see, the insertion of olefin to turn an olefin into more complex form. It's also used in pharmaceuticals at a very critical step. So the catalyst can reach 1 in 1 million. In other words, the catalyst's activity is very high. Another reaction is Negishi coupling reaction that also won the inventor a Nobel Prize. It's capable of coupling. As you can see, the conversion formula on the slide is also used in the synthesis of Elysium verum, also synthesis of natural pharmaceuticals. So Nagashira coupling reaction is a very powerful reaction, and it was published as early as 1975, also used in pharmaceutical molecular synthesis. As you can see, the Sanagashi coupling reaction is used to achieve a very important conversion step. And Suzuki Miura coupling is also used extensively in pharmaceuticals. It's capable of achieving the conversion as is shown in the formula on the left-hand side of the slide, achieving very effective and efficient coupling. And the catalyst used here is 1 in 1 million. In other words, such reaction is also highly efficient and active. And scientists also use it to synthesize natural ocean-based products. In addition to that, in addition to carbon-carbon reaction, it also has other applications such as the famous BH coupling reaction that was invented back in the 1990s. As you know that pharmaceuticals relies very much on the bonding reaction between carbon and nitrides. And this is a large industrial device. You can make it very large in pharmaceutical synthesis, whereas the catalyst you use is actually very small, showing such reactions are very efficient and effective. Catalani reaction is another reaction invented back in the 1990s. It's very useful. It has two valence and 4 valence as well as 8 valence palladium, showing palladium's variety and variability in terms of gaining and losing electrons. And this is also a coupling reaction using palladium under the influence of alkaline. And as you can see, such synthesized molecules can be used to further synthesize aconitum molecule, which is another very important pharmaceutical molecule. And the aconitum actually is extracted from a natural plant, showing how palladium can be used as a catalyst to play a very important role in chemical reactions. Another important form of reaction is CH activation, which is a requirement of green chemistry, and also it plays a very important role in the synthesis of natural things. You can also introduce light and electricity to achieve and promote similar palladium-catalyzed reactions. As was mentioned by previous speaker, carbonation or carbonylation reaction is very important, and palladium can also be used as a catalyst to catalyze such reactions. For example, a Singaporean company is capable of producing more than 300,000 tons of MMA, showing how palladium is used as a catalyst to catalyze carbonylation reaction. Palladium can be used as a catalyst in reaction oxidation as well as isomerization reactions, all these showing that palladium plays a very important role in industrial applications. Palladium is very important catalyst capable of contributing to reduction, oxidation, and isomerization of olefins, but I don't have enough time to talk about it. Currently, palladium, and rhodium are used in three-way catalyst, but I think with technology progressing, the amount of palladium used in three-way catalyst will reduce, bringing the cost down. As early as 2000, we started to study palladium, and we have developed a Huang complex. The Huang complex With the Huang complex, we're capable of doing a series of new CC, CN, as well as other type of reactions used in the synthesis of pharmaceutical molecules. For example, let me just give you an example that's shown here. You can do a stir at room temperature in order to have the Huang complex, and the swap of the two aminos are achieved easily with the Huang complex. We also use this to do the synthesis of a pharmaceutical molecule. In addition to that, we have invented a number of new reactions. For example, we use palladium catalyst to manufacture carbon-contained pharmaceutical molecules as well as very complex pharmaceutical molecules. Let me give you an example. The amino is alkaline, and the reaction, if you use alkaline amino, that means the palladium catalyst might be blocked. So we have this invention. As you can see, that we use inorganic ammonium salts to use it as a source of amines in various chemical reactions. That has successfully resolved the toxicity of catalyst, representing an innovative way of using it as catalyst. And we also use it in the relayed hydroamino carbonylation reaction using inorganic ammonium salts. What's more important is that we use palladium catalyst to achieve CH carbonylation. As you know that there is this traditional way, but we added a new step to this way. We're starting from the benzyl, and we rely on radicals, and we successfully turned toluene into phthalate acid, and we currently use it in industrial cases. So just give you a few summaries. Firstly, palladium has advantages as a catalyst as it has a varied reaction activity, is capable of being used in various types of reaction, is highly active. You don't need a lot to use it. In other words, it's characteristic of low catalyst loadings and it's reproducible. But there are also challenges. You need to have more diverse palladium catalyst and ligands to have a high active catalyst system, and you need to innovate in order to identify more areas for the use of palladium as catalyst. Thank you very much.